Hello, everyone will be ready. Welcome all of you in this our second session of Advanced Digital Signal Processing. So see, as we discussed in mornings, either today the objective of this workshop is basically to mainly facilitate you the application of the concept which we are learning in the DSP. So in that context, image processing is very important component where even see today it has been actually today it has been the major application in the signal processing, whether you take out the normal image processing, medical image processing, or the we say satellite image processing. Means even if in one word I say that the 99% of the signal that the 99% of the signal processing is basically consist of the image processing, it would be fine. So because we will take up the fundamental many applications of image processing. So today hello, hello, I I hope see I would I would be audible. Please, am I audible to all? Hello. I think there is some net for all. Just uh, let me reconnect it. There is some CCMP. Let me reconnect it. uh, so that there is some network problem. See, where do you see? Uh, Hello. No, is voice coming now? So please respond yes. See, there is some network problem. अच्छा। Actually, madam, there Funny. Funny. So now finally, see, starting with our image processing. See, now coming to this image processing, it is the main application area of the signal processing. Today, as we can see, when either it is any person's mobile or it is any social network site, it's all about the image only. When we more communicate through the image instead of the words. So before see starting with how much emphasis should I put it, so if it would be better if you may respond those people who have gone through the image processing and those who know if they have not gone through the image processing anytime. Can you please respond it in the chat box? Yes, those who have gone through it and those who have not gone through it. Utkarsh, okay. So many have, so many people have not gone through it. Okay, no issue. So just so we will try to cover it in the detail, no issue. So now see, coming to the part, see image processing, first we see to get the unit, what is the basic unit in the image. When we come here to the image, see there are many type of it. The first basically it is basically the spatial coordinates is there. Instead, like the other signal, which are basically time varying, the image signal is basically spatially varying. Here it is a coordinate, right? Coordinate XY coordinates in a 2D plane, in a 3D plane, it is XYZ. So that way the image is recognized. The important thing that time independent variable, which is the time in most of the signals, but here in the image it is the space. Then we will see the different type of operations which work upon the image which is there. For example, gray level mapping, non-linear gray level mapping. Why do we do it? We will go through it when we will discuss every topic. In non-level gray level mapping, it is gamma mapping, logarithmic mapping, exponential mapping, the image histogram, histogram stretching, histogram equalization. Also, we take the threshold in the image when we have to create the boundary, etc. And the color thresholding. See, these are the main areas which are mainly deal with the application part of the image. Our main emphasis in this workshop is basically the application, that how we can translate our concept to a at application level. So see, as the first part is spatial operation. Spatial operation is basically the basic term where all the things are, as we discussed, that the independent coordinate is space. As you can see in this, as you can see in this image here, that this rectangular box is there, where this unit, this unit what we are referring, it is basically the pixel. So what we are saying here, the pixel which has been basically marked here, that is in the some counting start from, it is many times one, two, three, one, two, three. Here, so it is 3, 3. What is its location? 3, 3. So this is the one. So this is the basic unit, what we are calling the spatial coordinate. When we are saying it is basically the point processing. Point processing means the most basic processing button place on the image. It means the same option image. It means the same operation as you can tell. How? What is this basically? G fxy. Fxy is basically the intensity of the pixel, right? So the gets changed. To those things, see. even when we are telling about the intensity, intensity varies from basically the black to the white. The white one is the full of the intensity. Gray level means basically that we are separating out the color information from the intensity. At the color level, if you see, it is the red, yellow. So these colors are there which we have separated out. And here our main focus is on, that's why we are saying it is basically the gray level, red, green, blue. So what we are saying here that this intensity is uh, changes when we do the some operation of the pixel. For example, somebody say that the GXY, the new pixel intensity has been redefined by relation fxy plus b. I have added some intensity to all the pixels in my image. So see, mathematically this operation seems again very boring here. But if you see actually here, what is happening here, that when b is less than 0, then you can see the image. It is basically dull image. It's like the in evening you can see. But when b is greater than 0, you can see that the brightness has increased. So such type of impact really makes image processing very, very interesting. What we are seeing here, that the operation takes place at the pixel level. Now another operation we see, that is basically the negative transformation. See, in the image, depending upon our different objectives, we want to focus upon the certain aspect of the image. We want to extract out some information. So for example, when you are seeing in this image, in this negative transformation image, you are seeing it on the left hand side some zebra like, and on the right hand side. So what the difference, if you could notice here, see the contrast has changed. What was the earlier white here, it has become black, and what was black here, it has become white. So as we discussed, see, mathematics is the core of the signal processing, but we want to see the application. So see this one operation, what we say basically the inverse one. S is basically the intensity here. L minus 1 minus R. What is L? L is basically the range. What is normally from the black to white? It is basically 256. So 0 to 255 it lies. So this basic we say it like the inverse operation. So this transformation takes place just by doing the one operation at the every pixel level. I hope see everyone you would be using basically the MATLAB and the Python, and there you are easily able to execute these type of commands. Another, see, this is not only limited to any to the medical applications also. What you are seeing basically original digital mammogram on the see left hand side. But when you take the negative part, see, you are able to see this the deformity here. So this is basically what we say this is basically the magic of these operations, because we want to see the want to see the deformity or the tumor, etc., so that we are able to get it with this operation. Now we come to the part C, mapping, non-linear gray level mapping. See, it is not always necessary that it is only one type of processing, as we have as we are discussing that it is the objective which basically defines that which thing will be suitable. So here, if you see, it is basically the gray level mapping. In gray level, what you are seeing, the line which is at the 45-degree, or which is the basically the baseline. There basically gamma is 1. And if it is gamma is less than 1, then in that case you can see the basically red line here, that it is in this way. What we are seeing, see, these are different operations, and when we apply on the different images, we are able to see the effect of the operation. So we take up the again, see, not only but we can, as we have already seen earlier in the last one, that the values which are less than the gamma equal to 1, they are on the upper side, and which are greater than gamma equal to 1, which they are on the basically below side. So there we are seeing at the different level of mapping. Because see, they are non-linear, they are like basically in a parabolic shape. So that's why we are saying it non-linear gray level mapping. What we see that what has been changed here, it is basically the gray level. Gray itself, somebody would be thinking, see, why are we interested in this only gray level? Can somebody answer on the chat box that why we are switching to this gray level to see the image in its color form? Can somebody get interested to see the image in its color image processing? I think everyone is with me. After a lunch, it is everyone would be awake. See, we go to basically the gray level uh, because see, it is it we say size of the image is very less. In the grayscale, it's only a in its color it becomes 3D. At R level, at green GB, it is at again it is your information contained many more bits, requires many more bits. While at the gray level, it is far means only one level, only gray level intensity is there, right? So that is the main reason, as it has been also answered by the Suman, right? So, and important thing, see, for our classification purpose, only that thing only matters. That is sufficient to make the difference. Please remember one thing that it is not the color where we are able to distinguish the image. It is basically their intensity only at the basic level. Anyway, now coming to the three different images, we again see we want to see the application of these operations at the image level. If you see the gamma, no gamma correction is there, you can see the middle image. If you see the gamma equal to 0.45, see again recall from the earlier image 0.45, it is towards the upper side of the gamma equal to 1. You see the basically image in that form little, and here if you see it is a more darker one, here it is a lighter one, so this is the difference. Here even you can see that the inform here it is it's like the in a sunshine atmosphere, here it is bit in a some darker atmosphere. Another example you can see, for example, the spatial view. If you take the any aerial view of any city, so that you can see the original image is there, and here you can see the real application. That in the transformed image, when gamma equal to 4 is there, it is less. It is greater than 1. So there the things are far easy to visualize than the original aerial image. So here another thing that the you can see also, see what is this on this black and the y-axis. Here it is basically the intensity is there. Intensity plot is there on the x-axis. It is the intensity on the y-axis. It is the count. What we are seeing here, see that in the original image that the higher intensities are more, but if you see in the transformed image, the intensities are distributed. When the intensities are distributed, so it is making better. Now coming to the logarithmic mapping here, gx. What is gxy? Again, it is the new intensity, new gray intensity level, and fxy is the old one. Here, when the c is some constant 255 log 1 plus mx, another exponential mapping is there. Here also we will see with the uh, example. Here you can see it here. Again, see this car picture is there with the number plate is there. Today, if you people would be observing that and the traffic violation, hardly any police personnel is there, but it is a camera that captures it. So here, if you see in this figure, logarithmic mapping bringing out the details in dark images. If you see here on the left hand side, here when we did the logarithmic mapping, so after it, now the image is basically far bit clear. It is far easier to capture basically the number plate, even other information also bit. And some bright images they are there if you want to bring out the detail. In that case, exponential mapping is better. So what is, again you can see the image which is of some technical devices there, and when you have taken it here you are able to see the information which is the brighter one in comparison to the car image. But when you have applied exponential, so this is the one. What is actually happening? Again, see, we recall the basic operation is basically the changing of the intensity of the pixel. The intensity of pixels have been changed here. So what we are saying that which are at the lower value, all these value have been basically increased. They have been, at the lower level, the values have been increased, and thereafter they are at later level. There is all are at higher level. But in the exponential grayscale mapping, what you would be observing that only the higher value, because that's why we consider the brighter image. Only the higher values have been changed, and they have been. See what is happening again here. It's a more gradual distribution of the pixel intensity. This is the see, there's a more gradual distribution of the pixel intensity. Now we come to the part piecewise linear transformation functions. What is piecewise? Again, in a some particular portion, in a some specific portion. Sometimes it is not necessary that we I want to carry out the operation on the whole image, but on some particular region only. That we call the piecewise. So what did we do here? Again, we do the linear transformation. How we are differentiating linear and non-linear. Again, see, as we have seen it and the exponential logarithmic, it is a non-linear one. And now we will see it is the linear transformation function based upon the mathematical function. So first we consider here intensity level slicing. Here we highlight a specific range of intensities of an image. Specific range. Remember, all the demarcation is based upon the intensity of the pixel of the images. So two different approaches are there. One is one basically where you highlight a range of intensity while diminishing all others to a contrast low level. So that's why we are saying intensity level slicing. You are cutting out basically some specific portion. That's why we are saying how you are cutting out that portion by highlighting a some range of intensity. So and preserving all others. So you can see the diagram here. This transformation. So what is that slice? What is that particular region? That is from A to the B. What is this A to B? A to B again, if you recall, it is basically the intensity. Intensity between, if it is a grayscale, 0 to 255. So within that range, if some range is there, we are able to translate into it with this linear function, intensity level slicing, and there you are seeing it. So how this is possible? Again, see by the some mathematical again operation, some translation. So this is there. Gray levels. Like another examples, you can see now the original image is there. So here when you are seeing in this original image, when it has been gray level slicing is there, so you are able to see the detail in the right one, in the upper one. and thereafter, and so this way you can see the background has been changed to the black and other values have been also highlighted better. Original image, again another example you can see. See what is difference here? Difference here basically, here the range was basically 150 to 200. Here also it is this one, and with the help of histogram you can see here. So here take angiogram, you can see basically this is the again human picture with kidney. So what you are seeing here that again in this image which is not bit clear, if I really want to see whether there is some problem with we want to identify the problem in the patient. So there when we have done this gray level intensity slicing, here the image is far easy to differentiate than the original one. And in a same way, you can see on, the gray in the area of blood vessels and kidneys were preserved while the transformation is taking place in the remaining area. Based upon this region where we are basically changing the intensity, can also be the bit plane. Here, what we are saying that each pixel in an image is represented by 8 bits. Why is the 8 bits? Because if you will consider, because level from 0 to 255, so when you will 8 bits, if that is the highest range. Imagine the image is composed of 8 1-bit planes ranging from bit plane to the bit plane 7. So we are saying bit plane slicing. So what does this? So here we separate out a digital image into its bit planes, which is useful for analyzing the relative importance played by each bit of the image. Uh, Here, what we are see considering, we have made the different planes. We have classified into the different bit planes, which are bit planes are composed of the specific ranges. It determines the adequacy of numbers of bits used to quantize each pixel, useful for image compression. Again, see, you can see the currency. It is a dollar currency. What you can see here that the bit planes one through each bit plane is basically the binary image, and when you have applied the operation, when you are able to see the number, it is far clearly visible in the last one. Each bit plane is a binary image. So using the different bit plane slicing here in the first A pod, it is bit planes 8 and 7 are being emphasized. In the B pod, it is bit planes in addition to 7 and 8, it is 6 has been highlighted. And in the C, it is the fifth one has also been basically slicing is there at that plane. So you can easily see the uh, change in the information that where it is easily visible. So these are the things again at the bit plane. Again, another applications have been shown that how which bit planes you should emphasize upon so that the different images you are able to find out where you are able to better differentiate the information in one image in comparison to the another image. Now we come to the part very important operation that even we considered earlier that it is a histogram processing. Histogram, as we have earlier just discussed it, that on the x-axis it is basically the intensity, and on the y-axis it is basically the count of those intensity. You can see here easily that in the original image it is maximum intensity lies between 0 to the 100 and very few in the upper region and in the middle region. So We directly work upon the intensity of the image. In earlier ones also we have been working out, but here we are basically checking out the things by drawing the histogram regularly. So that's otherwise, see, all these operations are not completely different from each other. They have overlapping thing, but but based upon the salient aspect, we are naming them as histogram or histogram processing. So in normalized histogram, what we are saying that normalized histogram is given by this one, this formula K upon Mn, where Mn is total number of pixels. What is this Nk? Nk is the total number of pixels in the range with the intensity Rk, R subscript K, R subscript K is the kth intensity value. And what is this H of K? H of K is basically the histogram. Histogram that how many times basically the repetition. It is the so as we have shown the diagram, see here frequency. So what is saying that zero, that the zero gray level has been in the total image, its count is basically 5, and the intensity pixels with the intensity 4 are basically number in 3 in number, this is 2 in number. So this is basically the overall composition, how many pixels are there of the different intensity that we are able to see in this image. Now see come to the application part, that how does it really matter. It is, if you see here, that this is basically the dark image, this is a bright image, this is low contrast image, this is high contrast image. So we these are basically image of the same thing, but how we can make them better. This is another one. Here what you are seeing, see what you are seeing here, that here the most of the pixel intensity lies in the this lower region. In the bright image it is basically in the, you see, at the higher end region. At the low contrast it is in the middle. It is a high contrast where it is equally placed, where all the intensities are there. So that's why you can see in this fourth image, high contrast image is far better in appearance than the other images where it is a uniform distribution of the pixel intensity. In the same way, you can see the again another image where it is dark image is there. See, dark image definitely means where the lower pixel values are there. Lower means it is near to the 0 1. So here you can see in this figure basically that it is um, maximum values are less than the half of the intensity. If you see that the high contrast image where the things are originally distributed out, right? So in this part, it is far better to see the child in comparison to the left one. Again, if you somebody say no, no, I will do the negative transformation. Negative transformation means whatever the less values are there, they will go on the higher side. In this way, what would happen? In this way, it would be a bright image. So, but it is not that clear like the high contrast image. Again, see what about the low contrast image? In low contrast image, all the things are basically shifted in between at the middle level. So remember one thing, that we are able to judge the final image after applying the different operation. It never ever means that I am able to know already in the beginning. First, we apply these mathematical operations on the image, and then we are able to cross check and validate these things. Now coming to the contrast stretching. In contrast stretching, or it is also considered as a histogram stretching, it is a process that expands the range of intensity levels. in an image, so it displays the full intensity range of the display device. You have already seen it that the when the range is basically more widespread, the image is far better in appearance, in conveying the information. So that's why we are saying in place of the histogram processing, we are saying histogram stretching. If you see this last diagram also, here also somebody has stretched the histogram. So so how do we get it? See, only what we need to do, only we need to find out the mathematical operation, which then we can make a loop. We can use a loop in the Python or in the MATLAB where the same operation has been performed on all the pixels. This is basically the mathematics is there. This is old one, this is new one, and this has been shown that the histogram is stretching. Again, see you can what you can clearly notice here that here the range of the pixel values is far less than in comparison to the when histogram stretching has been applied. So this simple fundamental is followed. See, any question at this level, if someone had simple operation, but very, very effective operation. Because finally, see, when we are classifying the image, what really matters that where we are able to where we are able to take the decision, where we are able to better see the information. So this mathematics is really very, very helpful. So another example, very, very important topic. If you are new in the image processing, then I should say that histogram stretching is the easier one and the very, very better option to start with the image processing. When you begin to apply, you will get very satisfactory result. Again, see, you can see the one of the image here where some near the seashore, some person is there who is trying to climb on the rock. When histogram stretch is there, the all the information see near the sea is very much better in getting the detail and getting the things when histogram stretch is there. What is happening? Again, the same thing is happening. Earlier, it was limited. Your range of intensity is limited only to the middle one, but thereafter, it has been changed to the very widespread one. But please note it, our our originality of the image is not lost. That's why you can see the peak pattern. See, you can see the peak patterns here, also here on the extreme right side. Because our so originality of the image is also remained despite the stretch. Another very, very good example. See, I hope see when many in medical image processing, it is very, very useful. Very simple operation, we say. Even see why does the simple operation matter? Because they require the very less cycle. It is far very easy to apply these things on the hardware. So more simpler the concept is, better it is in the real life application to apply on the hardware. Here you can see the X-ray of the chest. Again, if you recall, see in the morning, KL transform is used in the classification of the X-ray images. Brightness and contrast. Okay, brightness, if you see, if we go to the question from the sun there, pictures are all, see, we take up the examples. We go to the image where I can show you. Yeah, yes. See, here you can see. Here you can see this diagram. Here the image of a baby boy. Here see, when you seeing them, see bright, basically the intensity is on the higher side. what you are seeing, that the all the intensity are near more maximum intensity of the pixels lies near the 255 within this higher range, right? Dark is basically opposite to the bright one. Here it is in the lower. All are in concentrated in very very small region. Contrast, see, contrast means basically how much widespread is there. High contrast means high widespread. Low contrast means low widespread. Is it understood, Sandhu? The pictures are, see, don't see the picture, but see the histogram. Yeah, thank you. So this is the contrast. And remember, please remember one thing: there is no general rule that if I will apply this operation, that will work. Again, you have to apply the operation, and this is the novelty. You may apply the two operations sometimes on image. Even the order of the operations will lead to the different outcome. That is very, very key things in the medical image processing. Those people who are working, they would be very much aware about it. Again, if we see this image in this one, it is again the high contrast image that you are seeing there. It is the low contrast image because it is high widespread. So those people who are new to the image processing and they want to start it, please apply the histogram stretching, and 90% it gives the very, very good result. So now see, but there it doesn't mean that it will work everywhere. Some 10% things are there where it will not work. What are those cases? If just one pixel has a value 0 and another 255, histogram stretching will not work because then it will lead to a contrast one. Because see, stretching means basically the levels have been widespread. So that will be not happen if the only dark pixels are there with the intensity zero. What is solution? In those cases, the solution is modified histogram stretch, where small bins in the histogram are removed by changing their values to those of larger bins. See, what does it mean? If a significant number of pixels with very small and very high values exit, we still have and hence the histogram image remains the same. So another method is basically histogram equalization that we will see what happens. Please join. Yeah, they won't be. So, so, so please join. See, now actually today we are facing some network problem here. That's why we couldn't proceed further. So now just waiting. So any question, if somebody have till now when other people join. हम बढ़ रहे हैं ब्रेक के लिए बोल दो Hello. So please, after a see unwanted short break, we are coming back. So see, just recalling the earlier concept that at some places that histogram stretching is not a good option, but it is a histogram equalization. See here what we are saying that it is we are making the uniform. We are making the intensity values uniform. So what you are seeing here in this diagram, I hope so only same people are there. I hope other will also join. Yeah. So see what you are seeing here. Obviously, very simple mathematical functions. That what is this PR? This very probability function, probability density function. This tells about the probability of the different intensities between a range of 0 to 255. What we are saying when we replace it by uniform PDF, see, you would have read those concepts in the communication system. From the PDF, basically, PDF function, you find out the probability. So once you just replace it by the this uniform PDF, which is equal PDF, so then we are able to reach the histogram equalization that you are seeing here. That this function, this is almost some Gaussian function shape has been changed to uniform PDF. In another figure, see what you are seeing here that it is flat range, multiple values of the same intensity is there, right? Means with a very small means what we are saying that the many intensity values are the same in number. Remember, when they are same in number, this is not a good one to make a contrast. So what we are saying, so that has been changed. If you see this region, if you see this encircled region, that has been changed here. Why? Because to bring out the contrast, to bring out the clarity in the image. Are you able to follow? Are you able to see it? Basic notion. Please respond yes if you are with me. And really, it is a difficult situation when network problem comes. You can't do. It totally breaks the rhythm. Okay, thank you. So this is the one now we move to the one here, the frequency, what we are seeing. This is again at the now we see we want to see both the operations together. Many people would be thinking that where can we see the comparison of both the yes, we can see. Even it is the best thing in any technique that you put both the things together, histogram stretching as well as the histogram equalization. So what you are seeing here in the this is basically my original image. After the original image, when I applied the histogram stretching, this is the one. When we have applied histogram equalization, you see that the image details are far clearly visible here. So what is happening at the intensity level? At the intensity level, see when we are saying it is the histogram stretching, here stretching has not resulted into a likely impact. Why? Why it is happening? It is happening because if you can see that here, as we earlier and when we initially uh, understood that here the many low values are there. Maximum values are the in between range. That's why the histogram stretching has not worked. While in the histogram equalization, it has, see, now you see it has better able to lead the contrast in the image. Final objective is to bring the contrast, maximum contrast. So I hope so you would be able to see the limitation of histogram stretching and the advantage of histogram equalization. So another, see, diagram illustration of histogram equalization of 3-bit 8 intensity level image. Here what you are seeing basically the PDF probability density function when the initially it is a probability density function with the original intensity value, when it is a transformed value, and finally what transformation has taken place, and thereafter how the PDF has changed. So again, see, it is basically another image is there. This is original image. If you really see this image, see, it is not very clear image. You are not able to uh, explain it, uh, or in very dull image if you really see, because even if you see the maximum values are in the low intensity, less than the 100. So what would happen in the histogram equalized image? In the histogram equalized image, here if you see, here it is far better. Every nut, every its appearance, texture is very clearly visible. Not only the texture, but the in between region between the two nuts is also very much highlighted. So see, these are the, see, this is the best thing of the image processing. It's quite simpler. One mathematical function can really make a difference, and it is sufficient to provide you a one research paper. Just you have to pick up the one image and you have to check out. So if somebody really asks me that which one is the best area for the research, I will really say it is the image processing. Any question if you have regarding the histogram? Okay, no question. We can move further. But remember, histogram equalization may not always give the desirable results. When it is the case, when the given histogram is very narrow. Because if you really see the earlier diagram, see, earlier one, here it is a bit range between 0 to 70. And even the earlier one, here also it's a quite big range. But when it is a very small range, for example, almost in this region is 230 to 240, almost it is a range of 10. There, it is not there. Can we check out? Yes, we can check out. This is basically the one. See, this is the histogram equalized image. Again, see, no more any detailed information, no more any clarity is visible on the currency coins. So it has been shown the last diagram where we consider it. There's a transformation function for histogram equalization using equation 3.3.8. So all these see matter we have taken from our book. I will share you the book also. gonzalez. Now we say the local histogram processing. So in local histogram processing, only a part of an image may require enhancement. For example, as we have seen the last one, where only a small range is there, 240 to 250. In that case, it is best to perform local histogram processing only on the some patch of the image. So what do you need to do when you are working on the patch of the image? You need to define a neighborhood and then move its center from pixel to pixel. At each At each location, the histogram of the points in the neighborhood is computed. Whatever histogram processing was had been happening on whole image, now it will be centered upon some particular part. You can see the diagram. Original image is there. If we take the overall global equalization, that will be the result. But if we do the local histogram equalization, what is the neighborhood? The famous neighborhood in the image processing is 3 by 3. So here when you will do it, you will able to see the third image. So this is the case. So what we are saying here that histogram is basically the distribution of the intensity. Two different methods are there. One is basically histogram stretching, another is equalization, another is histogram processing in the patches. So at each location, here the histogram of the points in the neighborhood is computed. Either histogram equalization or transformation function is obtained. Again, see, we apply it, and when we apply it in the patches, so the effect comes on that particular patch or on that particular part. Not only see histogram is limited to these things, but today if you one of the very famous techniques basically histogram the gradient. When we will take up the later image processing part with the application, we will discuss that what do you mean by gradient. Gradient means angle. uh, Angle basically, see, for example, when I also want to see the relationship between means the change in the intensity between the two pixels, that is basically the gradient. So that histogram is called the HOG, and it has been very successfully applied in the many techniques. But to make the things initially simple, we have not included here. Spatial filtering. See, what do you mean by the spatial filtering? Spatial, as we are, as we have understood, the basic um, independent dimension in the image is basically the spatial coordinates. Spatial coordinates, it contains the neighborhood. See, not only one pixel. If you take one pixel at a time, it takes too much time. What we say, can we take the patches or can we take some local region? So that's why we are, because remember, our filter can, so that is the main thing. So that basically defines the spatial filter. So what do we do? Here we work upon those patches. So this, what you are seeing here, this is basically 3 by 3 region. It can be 3 by 3, it can be 5 by 5, 7 by 7. Depends upon the upon our objective. If our, but very famous is this 3 by 3. What do you mean by see filter? Filter in signal processing, see filter is the keyword. Filter is basically what you want to separate out. what you want to separate out from the original image. So here we are saying spatial filtering, that we want to extract out the s- information at a spatial level. What do you do in the filtering? See, filtering again, filtering again is one type of processing only. But here we are selecting out some region, filtering out some region. So based upon the objective, we name the different type of filtering. Low pass filtering. What do you mean by low pass filter? Low pass filter means we are able to filter out the low intensity values. High pass filtering, when we are able to filter out the high intensity values. So this way. Even this filtering is the basis of the recognition of the edge detection. Anyway, we will see it. Remember, the basic image processing now has been extended into a form of a spatial filtering. Median filter. What do you mean by median filter? When you apply the mathematical function, the median. From the 3 by 3 region, you apply the median and that value is converted into a one value. See, when this 3 by 3 region, when I apply that filter on this region, the median means the that median value is selected one. Mean filter means I will take out the average of these nine values. What will happen? That the neighborhood effect will come into that value. So, correlation and convolution. Again, see, these operations are very, very famous. Even today, you apply these things in the machine learning at the image level. We say 2D convolution, etc. Again, see, these are extended concept of filtering only. Template matching. What do you mean by template? Template means some specific pattern. Edge detection. Edge detection, again, see, it require means edge, whether you want to detect the vertical edge or the horizontal edge. So uh, different type of filters are there. Image sharpening. Image sharpening, see, as again, see, in histogram equalization, we have done the image sharpening. But for image sharpening, initially people started with the histogram, but now this concept has been also achieved through the spatial filtering also. So kernel size again, see how many pixels are you taking at a time. Most famous, as I told you, it is 3 by 3. It can be more than this. It can be spatial kernel size, it 2 by 3, 2 by 2. There is, but what we say, the very famous one is this one. You would be thinking, see, when we will apply the kernel at the corner, how would this operation take place? See, for example, this is a 9 by 9, and if I apply on this first pixel, this one, this root one, what would happen? See, then it's a simple one. Whatever the in the neighborhood is there, where image is not there, we will take the zero value. So this way we are able to operate this one. Difference between correlation and convolution. See, convolution is basically when we apply the filter, it is basically the we are doing, see, applying the filter, basically then we are applying the convolution. We are convolving that filter with that image, whatever that operation is there. So this is, as you are aware that it is basically a two-dimensional signal. On the x-axis also this vary, on the y-axis it's vary. That's why it is a double summation. It has been shown there. Here you are seeing it. For example, this is the operation has been shown. See what is there, that when you, what is the difference between correlation and convolution? If you recall, see, in convolution it is basically the flip one. See, for example, this is my filter. This W is a filter. 1, 2, 3, 2, 8. When it is flipped one, if you recall, see, xk hn minus k. This minus of k is basically a flipped version. So, right. So, what is happening? All the values have got flipped 8, 2, 3, 2, 1. That's why it is there. And that is multiplied with the every pixel. So that is the mainly difference. What do you mean with the zero padding? Zero padding again, see, it is the same thing as we have already considered when we apply on the boundary, etc. Or because you remember, this operation will take place when they both are of the same size. So then also we need to pad the zeros. Zero padding means we are adding the zeros. We are adding the zeros in the beginning. See, that's why only 8 is now able to operate with the 0. So here also it is same thing. So main difference is there, that here W is rotated 180 degree. Thereafter it is the position one shift, it is the same thing. And then you can see the result. It is a 1D correlation. It is a 1D convolution result. Basic difference is the one here, that here filter is directly applied. W basically shows the filter, and here it is 180-degree rotation. Remember, the again the basic theme of these operations are to bring the sum impact. People have seen the impact of the different values, and they have named the filter on their name. Sobel filter, Kenny as detection, etc., etc. You will see in the literature. But at the basic level, they are doing nothing, but they are extracting out either the values, either the vertical edges, horizontal edge, etc. You should never ever confuse. Only they are the different mathematical operations. So what do you mean by kernel? See, again, see, this image is shown that you can see all the things all together. As we use the notation H in signal processing to denote the filter, it has been shown here that H minus 1, 0 minus 1, it has been when it is working upon this middle values of the image. The image is here basically of the 5. Here it is 1, 2, 3, 4, 5, 5 columns, 1, 2, 3, 4, 5, 6. 6 by 5. So here what will happen? This 3 by 3 will work upon, where it's working upon, it is working upon this F2 by 2. Initially it will work upon this one, first this pixel, then this pixel. In this way, these many operations take place. That's why you are seeing when it is working upon F2 by 2, only one value is shown, G2 by 2. Accordingly, every pixel, when this kernel will operate, see where it, how do we, this H00 will coincide with the pixel value where it is operating. So in this way, we are able to get. So this is the thing. Same diagram has been shown that when it is a, how does the this operation take place? It is two-dimensional. Even see, you people would be thinking that in the MATLAB is basically matrix. In matrix, see, that's why this, due to these 2D operations are very popular in the MATLAB. The matrix, otherwise you would be thinking, see, matrix because it's a two-dimensional. That's why this is operations take place. Now here it is again shown that mathematically level convolution is similar operation with just one subtle difference, as we have considered it, that here it is a flipped one, here it is not a flipped one. original. See what we are seeing. See, how do you mean? Here it has been shown by this block that this filter V actually will coincide with E. This is particular part of the image. So V multiply by B, Z multiply by H. This is correlation where every same pixel corresponding to the same same position. D to the U, F to the X, H to the Z. But in convolution, it is flipped one. So how it will be the flipped one? Flipped one basically, this first one basically V will remain same, but this W will come in place of the uh, first this will flip, Y will come in place of the S, and then it will be flipped vertically. So W will come here. So that's why you are able to seeing it. That it is V cross E will remain same, but Z cross A. Z has come here. Because first we have flipped it around this middle one. Are you able to understand the flipped one? You play answer flipped. Flip is everyone aware? So here we are flipping around this UVW. This is the middle one. When we are flipping means we are exchanging the XYZ are going on the upper side, RST are coming on the lower side. And thereafter we are flipping around the vertical axis. First we have flipped around the horizontal axis, then the vertical axis. Then what has happened? Then this W will come in place of the U, and U will come in place of the W, and this Z which has gone earlier in place of the T, it will come in place of the X. So that has been shown there. See. So this is a key thing. See, whenever you talk about the filter, it is the convolution operation which decides it. So overall convolution is used for filtering and edge detection. Kernel elements are taken left to right, top to bottom. There's certain order when you perform these operations. Output gray level at a pixel is a weighted sum of the gray levels of pixels in the neighborhood. Means weighted sum means when we multiply all these 9 values for a 3 by 3 filter, and then the collective sum represents that one. Image elements are taken right to left, bottom to top. That has been shown that how do you perform this operation when even it is the same operation when you move across that summation. So okay, so now see this is very famous image. uh, are you able? You are able. You would. This is very famous image. See here. See we will see the operation of the different level of filters here. So what is in this image? See this is again at a pixel level, and see in the best way in the image processing, you take the some image, you apply the different filter, and then you see the resultant image. What is happening? So mean filter. So now we coming to the filters. So mean filter, as we discuss, see what do you do in the mean filter? In mean filter, see when you take the 3 by 3 block, you multiply all the values and then you divide by 1 by 9. It is not necessary that you have to take by the 3 by 3 neighborhood. You can take the 4 by 4 neighborhood also, 3 by 3. But then when how you will able to take out the mean? When you will add up all the values 1, 2, 1, 3, 4, 5, 9, 11, 13, 15. So this is how 4, 6, 10, 12. This is 60. So divided by this value. Mean filter is very popular even when you would apply it. It is basically low pass filter. Maximum, if you don't know anything for blurring, etc., it removes away. Noise reduction, it is very, very good one. So median filter. Image denoising, this is also the good one. So what you are doing here, in the median, when we apply the operation, you take the median value. Among these nine value, you take the median one. So see, have you really thought about it that how does this filter work out? Actually, it takes into account the neighborhood information because your neighborhood information is giving you the clarity in the picture. So that has been taken care by these different filters. So this is the median one. What we are saying, what happens in the median? If you recall, see it sequence, it arranges all the values in a sequence and the value at the middle one, at the middle order, because it is a 9 by 9, it is easy to get. It is, so what we say, it is, this is one is the 204, so this will be the value. What will happen when we'll apply the mean value? If we will apply the mean value, one will be multiplied and we will add up all these values and it will be divided by 9. So the value will come here 181. So what is the important thing? Important thing here is that the neighborhood information has translated to 204 value and here it is to the 181 value. So again, what you are seeing, this is the here filter. This W basically represents the filter and it has been how it is working upon the image. Mean filtered. See how this is the mean filtered. This is the median filtered. Here the mean filter is applied. Why we call it the smoothing filter? Because it uh, it basically smoothens. Smoothens means जो which is basically the mm, noise type mm, no, noise type problem is removed out. So that we are seeing here. This is original one, smoothened one. Again, you people would be thinking, see how this image is basically translated to the uh, pixel value. Can somebody tell how this? How can I find out the pixels from this image? Because you would be thinking that whatever operation we are applying, that is on the pixel value. See, it is very simple one. If you people have the time, those people who are learning the image processing, it's very, very simple. You take up the image and then you save it at some place. And when you will save it, and then just you when you will read this information, it will come out in form of the pixel value. Because when you will apply the MATLAB or the Python, it is stored in form of the intensity value. Before it, if it is a colored image, you can easily change it to a gray level. RGB to grays. Already some defined functions are there where you can easily convert it. Even see you can try on your own image where you can take your own image and you can see that how many pixels. Even see you can fix the size. You can convert it to a some standard size. For example, 50 by 50, 40 by 40. You would, it's a good operation. Yes, when we read the image, all the values are in the pixel format. Absolutely, when your image is actually stored in that form only. जो हम अभी see what we are seeing here, that is only the collection of the pixel value. It is actually the change in the intensity only. But those people who are new, please do that experiment. Take your own image, convert it into a gray scale, and then find out its resultant pixel value. This is a 5 by 5 smoothing filter. So what do you mean 5 by 5? It means our kernel is 5 by 5. Remember 3 by 3 is better one. 3 by 3 means when our neighborhood is 3 by 3 means when we are 1 upon 9. When 5 by 5 it is 1 by 25 upon that region. More neighborhood information when you will combine it, it is not the better one in this image. Average versus weighted average. So here also you are seeing it. See again as we have taken the example that in the filter you can either take the equal weight 111 or you can take the 121 2241. The see earlier filter we have seen it. So there also it has a different impact. Even the average filter, how much impact you are giving. Because see some to the or why we are saying neighborhood because all are see connected one 9 by 9 middle one which is the centermost it is the middle one and diagonally upward diagonally downward diagonally on the right hand side we are taking into account the effect of with the help of this filter. So here what we are seeing that not only the mean filter size matter, not only you need to take out the equal component, but also it may vary. And here it gives the different result. Remember, it is not always bring the more clarity. It also blurs it. For example, you can see in this input image when you apply the 11 by 11 kernel. See why it is happening? It is happening here because you are bringing out the more impact of neighborhood information. All has been lead to the same type of pixels. If you will really see the histogram, it is the same value. In the neighborhood, it is the same value. So that's why it is image smoothing example. In image smoothing example, what you say that it is in the original image of 500 by 500 pixels. Subsequent images show the image after filtering with an average filter of increasing size. It is 3 by 3, 5 by 5, 9 by 9, 15 by 15, 35 by 35. So this is the one what you are seeing here that more the blurriness is coming up initial. So what we are seeing here we are seeing the impact of the different size of the filters. But as I told you, the if we have the option, most popular one is the 3 by 3, where we are able to see the immediate neighborhood effect. Now we come to the part C, edge detection. In edge detection is a key thing because if you really see the image, it is basically collection of the edges. So what do we call the gradient? Gradient basically note down the change. So what we are seeing here that in the vertical one, this is the middle one. It is a 0 0. Here minus 1 1 1. Here it is horizontal private. It is a Sobel one. These are very famous filter with the help of the. Here you can see the impact of these filter. So input image is this one. When you applied the horizontal Sobel, see you are able to see you are able to note down the shape of the face of this person. Vertical Sobal, vertical when you did you apply it, see this information which is vertically when it is changing, that is basically more salient here. Combined Sobal, again see here threshold value is 25. Here you are also varying the threshold value. What do you see? So what do you want to convey? It is not any the some rule. It is you need to apply the thing and then you see. That's why. But remember, when something is not fixed, it allows you to very easily get a new result in the image related research areas, image related problems. Never ever think that somebody has applied some function, make some change in that function, what you are getting, what change you are getting. You can combine the two functions. That's why the image processing has the maximum publication. Only you have to, and when you see the impact, it is for encouraging for us to do the thing. Image sharpening. See, image sharpening means again we better highlight those edges. So highlight fine detail in image or another detail that has been blurred. Remember how did the image get blurred when we are applying basically the mean size filter. So you can see the operation I have. Again, it is the same way as we have applied it. Derivative part. See here, the in derivative, the what we see in derivative is a subtraction between the neighborhood region. Two times when it takes place, then it is a second derivative. So this is also the first order derivative. Again, that of fx plus 1 minus fx, as we told, it is a subtraction. Here it is fx plus 1 plus fx minus 1 minus 2fx. See, what is this fx plus 1? It is basically the value which is on the right side, it is on the left side, and your double value. Here picture is not bit clear, some problem slide. I will check out, recorrect it, and then we'll share with you. So again, see what is the role of the derivative to find out the edges. This vertical edge, horizontal edge. See, somebody may question, see, how do we get out the edges? Because see, edge is nothing but basically the change in the intensity of the value. आप कहाँ दिखेगा एज? जहां पे चेंज है चेहरे में. मान लीजिए आप कैसे देखते हैं कि आईज इज देयर, हेयर, नोज इज देयर, बिकॉज शार्प इंटेंसिटी में चेंज आ रहा है. सो व्हेन यू टेक आउट द डेरिवेटिव यू आर एबल टू फिगर आउट दैट चेंज. So this is basically the, it has been shown the impact. कोई image strip it has been shown that when you apply the first derivative, this information 5 minus, resultantly they have subtracted it 4 minus 5 minus 1, 3 minus 4 minus 1, 2 minus 3 minus 1, this information. So this is basically the first derivative. What did we recall? Fx minus fx plus 1. In the same way when we applied it, so this is basically the second derivative. It is a subtraction only. So again, what is the first derivative? This is the this one, this is the second derivative. Some people would be thinking, what is the rule of this derivative? Actually, in the different filters, we apply out the derivative only, based upon the derivative, based upon to finding out the edges. If you really see, सोबेल फिल्टर में क्या हो रहा था? फर्स्ट ऑर्डर डेरिवेटिव ही था. So with the help of this thing, you are able to find out the thick edges. And remember, sometimes your edge is basically in the form size of the ramp. Sometimes it is a straight one at the 90-degree. So there you have to use the different type of filters. It is not only because shape edges, because your edges may be in the different shape. For example, some triangular object has basically the ramp type of edge. Some rectangular object has basically the step type of edges. So you use a different type of filter combinations. So here we conclude it. So I think it's a bit difficult session for you after a lunch, but we don't have any other alternative so that we can finish it within a daytime. If you have any question, you are most welcome. So here we have basically discussed the basic operations of the image processing, where you are able to uh, see the many almost different type of image processing is possible with these limited operations. Actually, more extensive, more complex operations are the combination of these basic operations only. So, any question, if you please. See, both the sessions, see, please, you're waiting for your question. Please, and seeing toward the chat box. Chat. Actually, due to the disruption, very less people has remained. See, but actually, we sometimes if things are not totally in your hand, and we have requested them for the mm, avoiding this problem. Anyway, see, if you have, but these are problems are the part of the life. On. Now. So I will share these slides. Again, see, I have just announced it that you will have the quiz based upon these lecture sessions. So please prepare those it for getting the certificate. You need to get the 40% marks. These are very, very simple ones. See why we are putting this condition so that see at least you can go through it. And if you have any doubt, etc., you may raise it. So if you don't any suggestion, anything, not only question but also suggestion also here you can give me anything. Most welcome. See, attendee. I can go to the Vaishna. I think you are able to get the schedule. Vaishna, you emailed me. Vimal Prakash, Suman, Shrija, Ram Nivas, Raghav, Pranjal, Devashish, Anand, AM Shah. Whatever suggestion, whatever question you have, please give it so that we can make it better. Have you got the schedule? See, I have, yes, it has been shared on the WhatsApp. It has been shared on the WhatsApp. When will we having the quiz? See, quiz you will have on the this after Sunday. It is on the first. You have the Sunday. You will have a quiz on the second Monday. You have sufficient time. Objective questions based upon it. And see, also feel free. See, for example, see what I would suggest you, those people who are going through their different research, please type the in Google KL. See, for example, if somebody is working upon the medical images, type KL transform medical image and then see the paper and what content you have gone through and then just check out. And whatever difficulty, whatever you have, just post it. See, the best thing of these sessions that you are able to interact with those key people who are working there. Don't think that your question needs to be perfect. Whatever is in your mind, you can write it because it will increase your insight. That is a key thing. And it is a gradual process. See, it is not in a day. I also attended many workshops, but Along with the period, you then begin to appreciate the things. This is this is part of the process. With no questions, so I think we wind up this session. Thank you to everyone.